I'll have a crack at these recent specialist maths exam 2. Question 1. The contrapositive of this statement. If I have a tiger, then I have a cat. That is, if I don't have a cat, then I do not have a tiger. Question 2. The following statement, second derivative is equal to 0. The conclusion is the graph will necessarily have a point of inflection at x equals to 0. So if you look at the first graph, it does have a point of inflection, and if you try the second derivative, and solving x equals to 0, yep. So it satisfies the second derivative equal to 0, satisfying the point of inflection existence. And if you look at, let's say, the other graph, second one, we'll have a look at the second derivative of this rational function, 2x minus x squared. It's 0. And if we draw the graph, yeah, it does have a point of inflection here. Okay. The third function, x to the power 1/3, is equals to 0. It's undefined. But if we draw the graph, x to the power 1/3, you can see the concavity changes near x equals to 0 before and after. Therefore, even if the second derivative is not 0, the graph also has a point of inflection. So I think option C doesn't satisfy the scope or the condition of this if statement. The question wants a counterexample to disprove the statement, that is, to contradict the conclusion. So let's have a look at the last one. If we look at x to the power 4 minus x, well, zooming in a little bit, you see, okay, near at x equals to 0, y equals to 0, it doesn't seem to have a point of inflection because if you take the second derivative, x to the power 4 minus x, and solving x equals to 0, the second derivative is indeed 0. But the problem is, if you're solving, for example, 2 points, are the two x values near x equals to 0, you see positive, 0, positive. So the sign doesn't change. Therefore, option D would disprove the statement. Question 3. The graph of this rational function has an asymptote given by y equals to minus half x plus a quarter and a y-intercept of minus 2. This question is very similar to, let's say, 2023 VCAA Exam 2. I think it's question either question 2 or question 3. But what I'll do is I'll use y equals to expand fraction x squared plus a divided by b times x plus c. Given that, let's try each option. Say a equals to 2, and b equals to minus 2, and c equals to minus 1. So now you can see the expanded form in partial fraction form and proper fraction form. You have a fraction, and also you have a minus half x plus a quarter. So this indicates an oblique asymptote, okay? And yep, option A is correct. Also, we would like to get our y-intercept of minus 2. So we just need to double check if this graph really goes through, let's say, 0 minus 2. Yes, indeed. Therefore, option A is correct. It's now interesting to see for this year, they bring back a pseudocode question. So basically, the pseudocode defines a function square root x plus 1. Now, we'd like to, let's say, check through the codes, each line of code, and go through the while loop. And eventually, we want to print a sum. But notice for the CAS calculator, the word sum is a reserved command. Therefore, what I'll do is I'll define f of x equals to square root x plus 1 first. Then I'll call sum as s, assigned to 0. Let's call A1 assigned to 1, B1 assigned to 3. And the left, I just call it the letter L, L assigned to A, 1. Okay, now let's check the while condition. Is your L less than or equal to B, B1? That's true. So we can go assigning, let's call it V1 assigned to pi times f of L, whole thing squared. So we get a 2 pi. And then we need to assign a new variable s. S is assigned to s plus V1. So we get a 2 pi. Now we're going to assign a new left value. Left is assigned to the old left plus 1. And now that's the end of the first round of while loop. And I'll go back to check the condition again. Is my L still less than or equal to B1? That's true. Okay, so we can proceed with the next 3 steps. Here, here, and here. Okay, now let's check the while condition for the third round. Yep, that's still true. And then next step, assign L as plus 1 to a new L. That's 4. Let's go to the fourth round, number 4, fourth iteration. That's false. Okay, so the while condition is no longer satisfied. We need to jump out of the while loop. And then finally, what does it mean by print sum? That means you just enter the letter S and get the value displayed. So the final answer is option B. Moving on, question 5. Question 5 gives you a polynomial equation for variable z belongs to complex plane, a complex region. What I'll do is, because I defined so many letters for my previous page, I'll insert another problem to avoid any potential variable clashes. So for example, I would assign P of z to z to the power 3 plus a times z squared plus b times z minus 52. The next thing is we know z equals to 2 minus 3i is a solution to this polynomial equation. So I can get 2 minus 3i solved into the left-hand side and equate to 0. Notice, because z is a complex number, eventually the whole thing will be a complex number expression. We have real part and imaginary part. But I don't have to explicitly write them out. I just need to say, okay, I want to solve, let's say, a simultaneous equation. How many equations do I need? Actually, if we solve this 2 minus 3i into the left-hand side and equate to 0, we actually can get 2 equations. What I want to find is a times b. So what I'll do is I'll get, let's say, just 2 entries, but now I need 3 variables, a, comma, b, comma, r. R means the product of a times b. So we can just say r equals to a times b. And then P of 2 minus 3i equals to 0. So now you can see the cast spat out. A times B is minus 232. So option A. Question 6 is a decent question, I suppose, because the absolute value z is 1, but z itself cannot be just 1. Therefore, you can take some special values, for example, real. Let's just try, for example, I, 1 minus, we can take complex number I, because the magnitude of complex number I is still 1. Or you can take a minus 1 as well, so get a half. But in general, if I want to ascertain this result, I can just go for 1 minus bracket x plus yi, and then I'm able to get, let's say, minus x minus 1 divided by x squared minus 2x plus y squared plus 1. Notice that if the absolute value z is 1, for example, ABS, this thing equals to 1. We can actually get x squared plus y squared equal to 1. Therefore, this expression can be simplified to delete the y squared, delete the x squared, put a 1 here, you get a half. So option C must be your correct answer. Question 7. I think the intended approach or preferred approach is to demonstrate the process to get the u substituted, okay? So what I would say is du d theta is minus sine theta. And notice if you take the half multiplied by sine 2 theta, this thing will be sine theta times cosine theta, okay? Double angle formula. Also, theta equals to 0 or sine 2, u equals to 1. Theta equals to half pi aligned with u equals to 0. Cosine half pi is 0. So the whole integral becomes u equals to 1 to u equals to 0. And the top is just, let's see, this bit is actually negative du, okay? So we have a negative du multiplied by cosinus u divided by 1 plus u. Well, actually, I should write the du at the end, but it doesn't matter for now. Then with the negative, I can flip the limits, and I'll get, let's say, actually, I knocked out the minus sign already. So u over 1 plus u du, and I'll get 0 to 1, u plus 1 divided by u plus 1 minus 1 over u plus 1 du. And I believe that's option D, okay? But if the computation is a bit challenging in future, you see this kind of question, you can do, let's say, just go for half integral 0 to pi over 2. And you can just use sine 2t divided by 1 plus cosine t dt. You get a decimal approximation, but this method is only suitable when you have a multi-choice like that. Then you just evaluate, for example, it seems to be option D. Option D and the original integral gives you they both give you the same decimal approximation. So I believe option D is a valid answer. Option D. Question 8, we've been provided with a direction field or slope field here. So we would like to find the best differential equation to match this slope field. What I'll do is I'll add a graph. Notice the scale here is from -2 to 2, -2 to 2. But to make sure I have a 1-to-1 scale on my cast window, I would go menu for 1, and I'll use -3 to 3. Scale is 1. Y values -2 to 2. Scale is 1. So I'm able to get, let's say, you can see these nice 1-to-1 squares and grids. Then I'm going to use menu 3, 8. And now delete the 1. You need to delete the 1 here. And the differential equation you can use is like x squared minus y. Try the first one, option A, and give a possible, let's say, point. So we can sketch a curve to cut through this point. And don't click enter yet. You need to click the edit parameters and then change the field resolution. For example, the ideal number will be 30. So press OK, and then escape. So now you can see the slope field is sketched for you. And the first option actually produced a very similar slope field to this one. But how can I ascertain option A must be the correct answer? Well, you can try the other one and compare. But what I'll do is, based on the CAS calculator screen here, I will choose, let's say, this point is 1, 1. I'm trying to sketch a curve following the direction field, following the slopes, the segments. And then make sure the curve doesn't, cross or go against any slopes. So you can see this curve match this one. Option A is the correct answer. Question 9, moving on. Okay, parametric curve, surface of revolution from t equals to a to t equals to b. What I'll do is I'll write 2 pi, because this is rotation about the x-axis. I'll go from a to b, that's the t values, y times x derivative squared plus y derivative squared. And then I'll put a dt here. So the next thing is I'll do 2 pi integration from a to b you will have e to the power k times t times the derivative of kt is k. So k squared plus derivative of ekt will be k ekt. So k squared e 2kt. Don't forget to square your dy dt. And then the k squared under the square root is just a k. So I can just take out a k, writing it as 2 pi a to b k times e to the power kt times 1 plus e to the power kt squared dt. It feels like we need to do a substitution because option A doesn't have a k squared here, so that's not true. And this one takes out an e to the power kt, but that is not a common factor from both k squared and k squared e to the power 2kt, so that is not good. Then we need to decide, okay, which one is that, option C or option D? It seems that we need to take a u substitution, u equals to kt, and the u dt is going to be k ekt. Terrific. This is exactly my du dt. And also don't forget to change the variables. So I believe the option C is the correct answer because t equals to a will give me u equals to e to the power ka and t equals to b giving me u equals to e to the power kb. Something along this line, okay? And this bit and that multiplied by dt will be your du, right? All right. Question 10, we're talking about this curve 3 cos inverse x. So if you still recall from your unit 1, 2 learning, the graph of cos inverse looks like that. Because it has a dilation factor 3, the maximum y value will be 3 pi, the lowest value will be 0. But now I only pitch, let's say, a section of this cos inverse graph. So maybe somewhere here, I don't know, but this is, let's say, a comma, actually, this is not a comma something because that's y value. Okay, so actually I can say, all right, it's this bit maybe, rotated about, let's say, the y-axis. So now we can see y over 3 equals to cos inverse of x. So x equals to cos of y over 3. Why do I need that? Because I'm going to use the formula v equals to pi from 0 to a x squared dy. Next thing is I'll leave that with my CAS calculator to solve for the unknown a. Notice that the a is between 0 and 3 pi, okay? So it's always helpful to draw a graph. What I'll do is I'll put pi shift plus, and from 0 to a, and I'll get cosine y over 3 whole thing squared dy equals to pi over 8 times 4 pi plus 3 square root of 3. So I should be able to get that equation, and then I just need to solve that equation for a, 0 less than a less than 3 pi. Control enter. If it doesn't give you exact value, you can try control enter and see if you can identify the exact value from the decimals. So 3.14, etc. That must be pi, the most reasonable answer. Option D. Okay, question 11. Oh, I love this question. This is a differential equation solver question, to be honest with you. I just use DE solve. dy dx are treated as y dash equals to x squared times y to the power 3. Space button and space button, y of 1 equals to 3, x comma y. So I'm able to get, let's say, an equation like that. Then I would just solve that for y. I'll be able to get, let's say, 3 root something and minus 3 root something. Notice if you want the domain of this either solution, you can go for domain button, but to be honest, this condition imply the domain. So I just copy that down and use the solve button again, comma x. So I'll be able to get x less than 7 to the power 1/3 and 6 to the power 2/3. But this one, let me just show you. If you divide both top and the bottom by 6 to the power 2/3, you'll be able to get a 7 to the power 1/3 divided by 6 to the power 1/3. So option B is the correct answer, okay? I'll just mark this down here. Use DE solve. You might be wondering what if you are using a ClassPad? Well, using ClassPad, well, my main calculator will be, let's say, TIN SPY, but I can show you Math 3, D solve. Just get a Y here and a dash here, equal sign x to the power 2 times y to the power 3, comma x, comma y, x equals to 1, y equals to 3. And then you get this expression. But actually here, just to let you know, if you're selecting, for example, a solution, you must make sure you select the solution satisfying y1 equals to 3. So the only feasible option is this one. And to make sure the square root is defined, I'm going to copy the whole square root and put that under the solve command. Make sure it's greater than, let's say, 0. Why is that not greater than or equal to? Because you can't really get, let's say, this whole thing equal to 0. And you'll be able to get the answer, okay? So it's the same sort of idea. Question 12. A particle moves along a straight line with constant acceleration. It passes through the point A with velocity u, and it then goes through the point B with velocity v. So this is A, this is B. Acceleration, let's say, is to the other direction, and then u equals to u, v equals to v. Let's say the distance of AB is s. We can actually find the A here. So if we use v squared equals to u squared plus 2a times s, I'm able to get, for example, A equals to v squared minus u squared divided by 2s. The next thing is, I want to find a velocity in the middle. Let's call this point M. So this one is v equals to vs, something along this line, okay? Or actually, v half s, okay? V half s. So the acceleration is the same, but I change the condition. So now if we use vs squared equals to u squared plus 2a times half s. So I'm solving vs squared equals to u squared plus a times s. And I'm putting this thing into here to find, for example, vs squared. Then we find the vs. So we can use the CAS calculator to do that. Okay, let's just use, let's say this one. For example, if I do solve vs whole thing squared equals to u squared plus a times s for vs, given a equals to v squared minus u squared divided by 2s. You can see that answer involved a square root of 2 something. So the only possible option is dog, okay? Option C gives the square of the velocity, and option D gives you a positive velocity, and that looks like the only feasible answer, okay? Open window, person's here, let's say window, whatever, okay? That's the building. The point of projection, you throw something up, u equals to 20, and it's 50 meters above the ground. And then you have, let's say, a tray of the truck or ute, whatever it is, okay? This tray of truck is, let's say, 1 meter above the ground, directly below the point of projection. So what I'll do is I'll set s equals to 0 here. And throughout the process, the acceleration is minus 9.8 if we take the positive direction, the upward as positive direction. And then I'm going to say, all right, if it goes up a little bit, then it's here. Then my s is going to be minus 49, something along this line, okay? So I'm going to use, let's say, s equals to ut plus half at squared. So 49 equals to 20t minus 4.9 t squared. Grab the cas, solve minus 49 equals to 20t minus 4.9 t squared, comma t. You see, you need to discard the negative solution, and the positive solution is 5.80. There we go. That's question 13. I believe option C is a very close answer. I suspect if you ignored the condition of the one meter above the ground, you might get, let's say, a minus 50 here. Yeah, that's how you could get, let's say, 5.83. But usually that's asking for the time to land on the ground instead of landing on a point 1 meter above the ground. So that's a different story. Question 14, that's a very lovely vector question, I suppose. Left-hand side, we can write it like A dot B, magnitude times cosine theta. So that's how you expand the dot product in a different way. The right-hand side is actually the magnitude of modulus A times modulus B times sine theta. So that is the magnitude of parallelogram span out by A and B. The next thing is you can cancel out the magnitude A, magnitude B. So you get a cosine theta equals to absolute value sine theta. Then the angle between A and B is, I would say, it has to be pi over 4, isn't it? Probably you wonder why I'm not taking 3 pi over 4. Isn't that a valid solution? No, actually not. Because if you sub in 3 pi over 4, left-hand side would be, let's say, a negative value, and the right-hand side would be a positive value. So they are not equal to each other. So I think option B is the only answer, okay? And if you draw the two graphs, cosine of x, absolute sine of x, okay, pi over 4. You can see at 3 pi over 4, they are not intersecting with each other. This is the only solution between 0 and pi, okay? So that is question 14. Question 15, we have two planes, 2x, 2y plus z equals to 2, and ax plus 4z equals to 1. So we have n1 equals to maybe 2, 2, 1, okay? And n2 equals to, we don't have a y here, so we only have a, 0, and a 4. Now, the angle between the two planes is given by cosine theta equals to n1 dot n2 divided by magnitude n1, magnitude n2. We can use that, this is a 2 over 3, and get an equation to check each option. For example, what I'll do is dot p 221 comma a04. The bottom will be I don't have to use the norm command because this is just 4 square plus 4 plus 4 plus 1, that's 9 under the square root. That's a 3 times the square root of a square plus 4. So be able to get, let's say, 2a plus 2 divided by 3 root a square plus 4. Once it's equated to, let's say, 2 over 3, we can actually get, let's say, 2 over 3 equals to a plus 2 times 2 divided by 3 square root a square plus 4. So if you cancel the 3, cancel the 2, you get a plus 2 equals to square root. Oh, actually, bear with me. This is 16. I made a tiny mistake here. So it should be, this one should be 16. Yep, 4 squared is 16. So I can actually get, let's say, a plus 2 equals to square root a squared plus 16. So that's option A. Question 16. Okay, position vector. Velocity is perpendicular to acceleration when t equals to half. So what I'll do is r of t is assigned to n times exponential minus 2t, comma, minus t squared. And then v of t is assigned to derivative r of t, comma t, and a of t is assigned to derivative v of t with respect to t, and I can just solve dot p, v of half, comma a of half equal to 0 for n, given that n is greater than 0. Half e, okay? So option C is the correct answer. All right, so now let's move on and then insert another problem. Acceleration vector of a particle starts from rest is given by at equals to 4 cos 2t, 10 sine 2t, minus 6e to the power minus 2t. So we need to make sure when I sub in 0, the velocity gives me 0. This could be 0, this is minus 5, so that's no good. If I sub in t equals to 0, sine 0 is 0, and this is minus 5 times 1 plus 1, that's 2. No good. Okay, let me check, let's say option C. 0 minus 5 times 1 minus 1. Yeah, that's 0. That's correct. So that's 3 times 1 minus 1, 0. If you check the last option, this one looks like the derivative of a of t. We call it jerk, the rate of change of acceleration. Okay, it's not the velocity. So option C is definitely the correct answer. Okay. Anyway, question 18, we need to make sure that the two lines are intersecting at, let's say, okay, for 3t. And now we have r, lambda, s, mu, and t. We have totally five unknowns. What I will do is I'll just add a calculator. So eventually we need the 5 equations. What you can do is, let's say, R1 of, we can't find the letter lambda unless we go to the Greek letter template. So I just use R1 of x is assigned to, let's say, 2r negative 3 plus x times 1 minus 1, 4. And R2 of y is assigned to 1, 0, s. We don't have a j component, plus y times 1, 1 minus 1. The next thing is I'm going to say R1 of x equals to 4, 3, t. And the next thing is R2 of y is equal to 4, 3t, because that's the common point of intersection. Okay, so now you can see there are 6 equations. From the first equation, we have 3 components. From the second equation, y plus 1 equals to 4, y equals to 3. So basically, you can see the first bit here is the same as the second bit. Even if we have 6 components, we just need to use 5 of them, okay? 5 of them, because these two are repeating themselves. These two are repeating themselves. So what I'll do is I'll use the solve button. But I want to put, let's say, 5 equations in one, let's say, matrix. So I need to bring this down. Once I bring this down, how can I, add more cells? Shift, enter. Not this enter button, use this one, okay? Changing lines button, shift, and this button. And then I'll go for y equals to 3 and shift s minus y equals to t. So altogether, we should have, let's say, s minus y equals to t. And then I go for comma x, comma y, comma rst. So you'll be able to get, let's say, rst, they are 585, okay? 585, so I think that's option D. Well, that sounds like a more algebraic question rather than calculus, but anyway. Question 19, the plane with equation x plus y plus z equals to a intersect the coordinate axis at 3 points that forms the vertices of a triangle. Ah, this is a lovely question. So if you draw a diagram, this is one of my favorite topic, geometry. So if this is X, this is A unit, this is Z-axis, this is A unit, this is also A unit. Just let X, Y both equal to 0, you get a Z equals to A. Vice versa for the other two intersections. Now, if you notice the pattern here, okay, what I'll say is this thing here, that will be A times root 2, because this is a right angle triangle. Same reasoning here, you'll be able to get, let's say, this is A times root 2. This thing here, it's A times square root of 2, okay? So in order to find an area of this equilateral triangle, I'm going to use half times one side multiplied by another same side. So it's square multiplied by each angle is just 60 degrees. So we multiply by sine 60 degrees. So eventually you'll get a 2a divided by a, 2a squared actually, divided by 2 times, actually sine of 60 degrees. You'll get a square root 3 divided by 2. Okay? Option B. Oh, we have a final question here. Let me just wait and get that load up. All right. So now we only have one probability and a statistics multi-choice question. We would like this combined variable. We call it W equals to 3P plus 2Q minus R. We want this W to be greater than 25 and do the standardization. First thing is we need to find the combined expected value or combined mu. So 3 times negative 2 plus 2 times 3 plus, actually this is negative 5. So you will get, let's say, minus 5. And watch out for the variance. This time it's a linear combination involving some dilations. So the variance W will be 3 squared variance of P plus 2 squared variance of Q plus negative 1 squared variance of R. So eventually you'll get, for example, 9 times 2 squared, that's 4 from here, and a plus 4 times 9 plus 1 times 36. So eventually you have 3 lots of 36, which is 108. Therefore, to standardize this probability statement, W is greater than 25. We use Z equals to, in this case, W minus mu divided by sigma. And that is probability W greater than 25 minus negative 5 divided by square root of 108. Because 108 is the variance. I need to get, let's say, 25 plus 5 divided by square root of 108. So that is lovely. Probability Z greater than 5 root 3 divided by 3. And that is option A. Okay? So here ends my quick discussion to the multi-choice questions.